We are looking at the aftermath of a massive, coordinated financial breach. The network is down, the incident response team is scrambling, and a trail of compromised endpoints is scattered across the organization. To understand how the infrastructure collapsed, we have to start at the exact point of entry. The initial wave of the attack relied on two distinct types of malicious software. First, the attackers introduced viruses, which are programs that require an existing host file to attach to in order to replicate. But they simultaneously deployed worms. Unlike a virus, a worm is self-sufficient. It replicates and propagates itself across systems without needing a host at all. Once those initial payloads found a foothold, the attackers deployed Trojans. By disguising themselves as harmless or useful programs, these Trojans quietly installed rootkits in the background. A rootkit embeds itself deep within the operating system tools, providing the attackers with hidden, persistent access to the machine. But the malicious software didn't execute itself. Take a close look at this email message. It looks like a standard Netflix validation alert. In reality, it is a phishing lure. An authorized user on the network received this message, believed the social engineering tactic, and clicked the link. That single click triggered the credential theft and initiated the entire software breach. Technical firewalls sit idle when an authorized human being is successfully manipulated into opening the front door. Breaching the network provides the access, but the operation's success depends on how the attackers monetize that foothold. Look at this red interface on the compromised laptop. This is ransomware. Once inside, the malware systematically encrypts the critical files on the target system, rendering them inaccessible to the company. The attackers then hold the decryption key hostage, demanding a multi-million-dollar payout to restore operations. While the ransomware holds the system hostage, secondary payloads are operating silently in the background. You might see this deceptive prompt pop up, warning you of an infection. Clicking it often installs spyware or adware, which logs every keystroke, harvests passwords, and tracks user profiles to sell to third parties. Blaming employees or using fear tactics fails to improve security. Instead, risk officers implement proactive controls. This means setting up application whitelisting, which only allows approved programs to run, and conducting structured training to test users with simulated phishing emails. Defeating monetization-driven malware requires building a resilient culture of awareness. Relying on an antivirus to catch a signature after the fact is simply too late. Up to this point, the infection was contained to localized endpoints. But the situation deteriorated when the attackers weaponized that access to escalate across the massive network layer. In this diagram, we see the raw mechanics of a denial of service, or DDoS attack. A specific method, called the ping of death, generates oversized Internet Control Message Protocol packets. These packets are larger than the allowed bytes, so they fragment. When the user system attempts to reassemble them, the oversized packet overwhelms the memory and causes the destination to freeze and crash. Now multiply that single source. When an attack is distributed, the target isn't fighting one machine. It's fighting a coordinated flood from tens of thousands of hijacked zombie computers simultaneously. On the ground, the organization feels this immediately. The available network bandwidth drops to zero, and legitimate users experience a severe, crippling degradation in system performance. When defenders see an unexpected, massive loss of bandwidth, they have to assume they are dealing with an active weaponization of their infrastructure, rather than a hardware outage. The attackers deployed the DDoS as a dark DDoS, a tactical smokescreen designed to fix the attention of the IT department on a noisy external threat. While defenders were busy fighting the flood, a stealthier attack was hitting the architecture. Every input field in a program has a defined capacity. When programmers write code that fails to check the size of the data coming in, attackers can execute a buffer overflow. They fill the buffer with executable code until it spills over, overwriting memory and granting the attacker elevated administrative privileges. With those elevated permissions, the attackers initiated a man-in-the-middle attack. An unauthorized node injects itself directly between two communicating systems. To both the sender and the receiver, everything looks normal. But the attacker is sitting in the middle, intercepting confidential information and altering the data stream in transit. The attackers leveraged this position to pull off network session hijacking. They joined active TCP sessions, tricking systems to recognize the intruder as a verified, legitimate party. Surviving this kind of network escalation requires two things. Programming teams must adopt DevSecOps practices to check inputs and prevent buffer overflows, and network administrators must mandate encrypted protocols so intercepted data remains useless. Even if you lock down the software and secure the network protocols, there is a third reality that threat actors exploit to guarantee access. They breach the physical perimeter. A direct physical hardware override bypasses advanced digital network and software firewalls. Look at the exposed circuitry of this keyboard. Someone placed this tiny Wi-Fi keylogger between the keyboard and the computer. It registers every single keystroke, including passwords and pins, and wirelessly transmits that data out. Antivirus misses it entirely because the compromise is physical. We trust physical doors to protect server rooms, but an experienced attacker can manipulate the tumblers and clear a standard deadbolt in under 30 seconds. To counter this, risk officers mandate the replacement of physical keys with security card networks. A card system generates exact entry logs, detailing precisely who entered a room and exactly when, creating a digital trail of physical movement. Financial threat actors will exploit whichever door is left open. Defeating them requires a unified defense, an educated user base, encrypted network protocols, and a physical perimeter that records and restricts every point of entry.